Uh, so I'll be solving this problem. Today's lead code question is binary watch. So let me look at the problem. Binary watch has four LEDs on top to represent hours and six LEDs on the bottom to represent minutes. Each LED represents a 0 or 1 with the least significant bit on the right. What does that mean? Okay, for example, the binary watch reads 4:51 mm, hours PM minutes. Okay. Now I get it. You have to add the values minutes to get the total minutes. 32 plus 16 plus 2 plus 1, 48 plus 351. Ours is 4. Okay. Now, given an integer turned on, which represents the number of LEDs that are currently on, ignoring the PM. Okay. Written all the possible times that the watch could represent. Okay. For example, if there are 5 LEDs turned on, what are the different possibilities? Okay. So we have mm, four lights, four LEDs for hours, and six LEDs for minutes. Now, out of this turned on, you can split these between hours and minutes, right? If there are like four, turned on is equal to five, you can take one for hour and remaining for minutes. And of those six, you have to pick the remaining. For example, if you take hours to be two, you pick two from four, right? Four C2, and you pick remaining two from six C2. Mm, but let us look if it is that only. You may return the answer in any order. We have to return the possible times actually. Okay. So yeah. For example, ours must not contain a output. Our must not contain a leading zero. For example, 0100 is not valid. It should be 100. Okay, there shouldn't be any leading zeros. What about trailing zero should be there. The minute must consist two digits. Okay, so it should contain a zero leading zero. You can't say two. You should say 02 because two is vague. Either it should be 02 or 20, right? You shouldn't have that ambiguity. Okay. Mm. For turn on is equal to 9, we're saying what? Output is 0, empty. Why? You could have picked 4 here and 5 here, no? Hmm. So what's stopping us from doing that? Binary watches LED. Okay. Hmm. Hmm. Must contain. It should be Why is it 01? Okay, 001. You have turned on one LED in minutes. These all one, right? And then one, two, three, four. Okay. For example, if for n is equal to 9, hours you take 4, minutes you take 5. Okay. Now that means you're calculating all 1, 2, 3. Okay. There is AM and PM only. So if it is PM, so his hours can only go up to right how much? 12 only. It can't exceed 12. So so you can't pick all the values, all the LED lights on ours, because if you pick all, the total number of sum is equal to 8 plus 4 plus 2 plus 1. It is 15, but since we have AMPM method, 15 is not valid. Okay. And in the minutes case, I think sum goes to 64 or 63, right? So here also you can't go, it can only go up to 59. So you need to, okay. So for hours you can't be having 4, so hours can only be 3. And what if you pick these 3? 8, 4, 2, if you pick, it will be 14. So that also you can't do. Okay. Okay. So basically these are powers of 2, right? So what if we say like there is conditionality, like directly you can't say either I will turn on this, for example, so the eighth position I can turn on in hours or not. That depends on like the remaining, right? If there is 4 and 2 also, you can't turn on 8. But if it is they are not there, you can turn on 8. Or you can do something like mapping, right? For example, the range of hours is from 0 to 12, right? 12, 12. And for minutes it's what, 0 to 59. What if you count like the number of bits you are taking? So for 00 it's 6 bits, right? For 1 it's 1 bit, for 2 it's 1 bit, for 3 like that you keep on doing. And for 12 how many bits? 2 bits, right? Similarly you calculate the number of bits for this also. And now you'll be saying like, okay, I'll have 1 bit from hours, the remaining bits in minutes. So you can go all the minutes and you can make an answer. But here what they are saying is return all possible times which the watch could represent. Okay, you may return the answer in any order it seems. What are we missing here? It has to do something with. Mhm. For example, you can't pick 12:59. 1259 is invalid. 1259, 1259 is valid. Okay. 059 is valid. Okay. 1200 is valid. Okay. 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 So that means we can do this. Hmm. Then we can iterate over each hour. For example, if turn on is equal to 1, we'll go. Okay. We'll start with 0. Hours is equal to 0. Now minutes is equal to minutes is equal, or what? Minutes. You how many bits I used? 0 bits. So I will use the remaining 4 minutes. I'll say okay. Now hours is this. I will loop over this and this, right? And number of bits sum is equal to uh, turn on. So I will add this answer. In case of turn on is equal to 9, you will see that no, for nobody else, that it has that many bits, so you will skip it. Hmm. Let's look at the edge cases. If turn on is equal to 0, you will only give 0 0, right? No bit is there, means time is 0 and 0. Okay. Hmm. I think this should be working. So we should be able to, instead of storing that, we can easily calculate for a number, right? Number of bits. So let's try to calculate the, for example, if you have a number n is equal to something like 10 10 11 00, something like that. Now I want to return 4 because there are 4 set bits. There is a formula to calculate the number of set bits. You can use a while loop, calculating the reminders and all, and you can maintain a code. But using bit masking or bit manipulation, can you do something? For example, okay, let's just go with that only. Hmm. Okay, I will just write the function. Basically, what I'm saying is, get get set bits, or it is a better name, get count and then saying let count is equal count is let's count is 0. Okay. And while n is existing, that means n is not 0. That means the bit at the least bit is now 1. So you do count plus plus, and now you want to right shift because you want to keep reducing your solution. So n is equal to n, no, n this one. Okay, something like that, and then you return. Hmm. And then you iterate over hours and minutes. Okay, let's see if it works. So time complexity is like for bits. For every number you're calculating, this will take, first case, when you're going till only 59. 59 has how many bits? At most, like 2 power 30 to 5 6 bits, something like that. So it's constant, and for loop is, like in order of 10. This is order of tens only. So this will be order of 100. So yeah, it should be constant. It shouldn't be taking too much time. So let's say int get count int n. Okay, int count is equal to 0. In the worst case, while n, if n is 0, you return count only. Count plus plus and n is equal to n. Right shift is this only, I think. Yes, you're. The direction of arrow gives the direction of move and shift. Okay, you return count. You return count, and now let's store the answer in vector strings. Okay, answer. We're saying for int height h will take h is equal to from 0, h is less than or equal to 12, and h plus plus, and the minutes, right? For m, int m is equal to 0, m less than 59, because m can't be 60, m less than 60, m plus plus. We're saying int h leds is equal to, okay, we can move it up. You can say h leds is equal to uh, get count h, right? Now if get count m is equal to what, the remaining bits, turn down minus h leds, then what are you doing? You got an answer, right? We also have to worry about trailing zeros. Okay, we have to convert m into string. Okay, okay. Mm, okay. Answer plus is equal to, okay, for if it is 0 1, you just add it like 1 only. So answer plus is answer, uh, string s is equal to 2 in a 2 in drive some function, 2 string h. Okay, and this s1, let's put it s1, using s2 is equal to, now if minute is less than 10, you add 0. If no, if m less than 10, you add 0 plus 2 string m, else it's only. Okay, answer dot push back s1 plus, okay, you forgot this, plus s2. Now I will return answer. Let's see. This has to be incompatible. uh, where is it? Okay, two string m, two string m. I think there is a better function. Okay, let me keep it two string for now. Let's look at the issue. In case of turn on is equal to 1, we're only giving y. If h is equal to 0, m is from 0 to 60, you're saying get count of 4. Get count of 4 while 4 count plus plus. Okay, I think I have to only count if the parity is the number doesn't exist. Existing means doesn't mean it is. For even also the number is greater than 0, but doesn't mean you have to count, right? So okay, okay. It passed two cases. Let's try this edge case also before submitting, which is turn on is equal to 0. Okay, so it passed. Oh, wrong answer. Okay, we gave 12 also. Did we give it multiple time or like we should be giving 12? For n is equal to 0, 8 and 4. 12 is correct only, no? Why 12 is not there? Hmm, I don't understand. Number of bits in 12, how many? In 10, it is 10 has 8 plus 2. 12 is 8 plus 4. Hmm. Okay. There is only 11. There is no 12 59, bro. 11 59 after 12. 12 again, 12 from 12 0. Huh? 11 59 after what do you get? 0 0. Okay, if I make it 11, then what happens? It passed. Okay, that means there is no 12 o'clock. If I submit it again, it got accepted. Yes, I restarted the streak. Now let's look at the solutions. First, let's look at the hints. Simplify by seeking for solution that involve comparing bit counts. Con- uh, Comparing bit counts. I think that's what we are doing. Anyways, consider calculating all possible times for comparison purposes. Mm, let's look at the solution. Editorial enumerating hours and minutes. So implementation is not coming up for some reason. Implementation. Okay, okay. The built-in popcorn. Yeah, I think this only. So we can just delete this function and just say built-in popcorn, right? Here also, this is much better. Like if you, okay. Anyways, built-in popcorn. Yeah, you can just add because I think it's very fast function, so it doesn't take. Yeah, they also used two string only, so that is good. Instead of doing it separately, we could have just made it in a single. Anyways, another one is binary enumeration. Okay, what is binary enumeration? Binary, another way to enumerate valid times is to consider all possible configurations of the lights. There are total 10 lights, 6 down, 6 up. Okay, each configure can be represented by a 10-bit binary number, right? Where the higher 4 bits represent the ohm. Yeah. Mm, for each configuration, okay, 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 okay. All the possibilities. You're saying these are possibilities. First, mm, like the higher four significant is for like hours, and the remaining six are for the minutes. And if you're saying if h is less than 12 and m is less than 60, and total count of I is equal to turn on, you should say, okay, okay, makes sense. Hmm. My recursive thought process, lead code solution. Hmm. Let's look at some top solutions. Mhm. Oh, it is my solutions only. We don't have solution, I think. Hmm. Thinking about bit count, then I realize we already have inbuilt function. Yes, we have. Okay, I think that's it. Done for today.